Hi, welcome. This is my original design of electrical blood pressure monitor, and this is the poster. It contains 5 sections, which is introduction, the theory of project, technical method, OLED display, and the Arduino Uno controller. Now I'm going to introduce blood pressure monitor. Nowadays, people's living standards have improved and people are paying more attention to their health. Blood pressure is an indicator of human health. If the blood pressure of elderly is too high, it will lead to the hypertension, which will cause the cardiovascular diseases, and it is also an invisible killer of the elderly people. And blood pressure monitor is a medical device to measure blood pressure. And now you can see the left one is mercury monitor, and the right hand side is electric monitor. And people used to use the mercury monitor in the hospital, but it's very difficult to measure the blood pressure at home. Thus, the right hand side is the electric monitor, which is very easy to use and very convenient. Also, mercury monitor must be measured by doctors wearing stethoscope every time. So the measurement process is complex, and each doctor can only measure one person at a time. And however, electric monitor can use every time, everywhere, and also it can store the measurement in the monitor. Now let's move on to the theory of the project. And the supporting theory is based on the oscillometric method. The relationship between systolic blood pressure and diastolic blood pressure, mean blood pressure and cuff pressure, was established by oscillometric method. The principle is that the pressure sensor in detection devices senses the initial and maximum position of the artery under the sleeve band, converts a physical pressure signal to an electric signal, and after amplifying and filtering, we can extract the static pressure DC component and the position AC component, and give the corresponding collection and processing to obtain the required measurement. And the schematic diagrams of the blood pressure of oscillometric method is shown on the screen. And when the cuff pressure is higher than the systolic pressure, the artery is closed, and there is an oscillation wave due to the pulse. When the cuff pressure is less than the systolic pressure, PS, the amplitude increases. When the cuff pressure is equal to the average pulse pressure of PM, the artery was under load, and the amplitude reached the maximum OM. When the cuff pressure is less than the diastolic pressure PD, the artery vessel is fully expanded during the diastolic period, so the amplitude of the wave remains at a small level. Thus, the cuff pressure corresponding to the envelope of the oscillating wave will directly reflect the artery blood pressure if the oscillating wave is continuously measured during the cuff deflating process. And the size of the OS and OD can obtain from the following equation. Now let's move on to the technical method, and the design flow chart is shown on the left side. We can use Arduino Uno to control the pump and the cuff, and it will send the signal when we use pressure sensor to detecting, and the small signal will go to high pass filter, to amplifier, and then to low pass filter. to get a larger signal and less noise. Then that signal will go to the Arduino Uno, and which is detectable and readable, and we use coding to program them. And the measurements will shown on the OLED, and some data we can connect to outside environment by using Bluetooth module. Can connect to PC or mobile phone. And this is the overall specific pressure sensor, bandpass filter, amplifier, and the reset circuit. The function of pressure sensor is to detect the signal, and the bandpass filter is to remove the large noise, so that we'll get a purified signal. And the amplifier is to enlarge the signal to reach a minimum readable value of the Arduino Uno. And the reset circuit is to restart the microcontroller activities, and it ensures the power supply of the system is stable at the correct levels. And finally, we go to the OLED display. This is the OLED I have made for the project, and as you can see the blood pressure test, and we can see the high pressure and low pressure of the measurement. And the screen is big enough to show the data set, show the measurement. And this is a microcontroller, and I use Arduino Uno since I have made some similar project, and I can use the program skills I have learned during the past 3 years to program, and I can show the results. And since there's a Bluetooth function of Uno, so I can store the data set and send it to the personal PC and mobile phone.